Hello students, so today I will continue with the variation of periodic properties of elements along the period from left to right and down the group. Yesterday we had made the beginning and we have studied 7 properties variation along the period and down the group. Let us first revise that before we start today's topic. Now, first is atomic size. So if we are moving from left to right, then as the period number remains same, so number of cells will remain same, but as we are moving, our group number will go on increasing, so our nuclear charge increases. So as the nuclear charge increases, the radius of the atom will decrease. So that's what you can see in the slide. Atomic size decreases from left to right. Now, when we are moving down the group, then number of cells will increase by 1, because suppose we are going from period 3 to period 4. So number of cells will increase from 3 to 4. If we are going from period 4 to period 5, number of cells will increase by 1. So when we go down the group, as number of cells increases and number of orbit increases, so atomic size will increase. Then second parameter we studied was number of valency electron. Note the word valency. So as we move along the period, we are moving from group 1 to group 2 and so on. So my valency electron will go on increasing from 1 to 2 as we move from 1 to 2. Then we should consider only A. Then when we go to 3A, the electron will become 3. When we go to group 14, it will become 4. When we go to group 15, it will become 5. And finally, in group 18 and group 0, it will become 8. In between group 3 to group 12, number of valence electron will remain 2. Is it alright? So number of valence electron, so we can say it increases. But when we go down the group, as we are told, whichever is the group number, that are the number of valence electrons. So valence electrons would remain same. Then comes metallic character. We have seen on left hand side we have metals, on right hand side we have halogens, which is non-metal. So gradually metallic character decreases, and we are going to learn in detail today. If we go down the group, then we know that on the top, like we have got lithium in group 1 and below we have cesium. So cesium is more metallic in character because the number of cells have increased, so the force of attraction between nucleus and outermost orbit electron will decrease. So it will become easier for the electron to come out. So we say its metallic character increases because metallic character means easiness of removal of electron or loss of electron. We will be studying this also in detail today. Non-metallic character would be opposite to it, because first is metal, last is non-metal halogen. So non-metal character will increase along the period and it will decrease down the group. We will discuss this today. Then I told you to remember that electron affinity, electron negativity and ionization energy all increases from left to right in a period, and they decrease as we move down the group. The reasons were explained to you yesterday. Now, I told you that to see about electron affinity carefully. This I explained to you yesterday, that electron affinity increases from left to right along the period and it decreases as we move down the period. I told you that there is an exception once, that fluorine is having minus 3.6 EV and chlorine is having minus 3.8 EV. So we will see that chlorine is having more electron affinity. Electron affinity means energy released when one electron is absorbed or is taken by an atom. So in case of chlorine it is minus 3.8, negative sign shows energy is released or it is electron affinity, and fluorine is minus 3.6. So this is only an exception. Otherwise, if we move down the group, electron affinity decreases. Like you can see, for lithium it is minus 0.6, whereas for ruthenium it is minus 0.5 electron volt. Is it alright? So now we will start today's topic. So as I told you that we will be discussing about metallic properties. How does they vary along the period and how does they vary down the group. As I always told you, keep your periodic table open so that you can refer to it for easy understanding. So keep the periodic table open and then we will start this metallic properties. Now, what do you mean by metallic character? Metallic character means an atom is having tendency to lose their valency electron. Like sodium is having electronic configuration 281, so it wants to lose that one electron. Then if we take magnesium, it is having 2 electrons in the outermost orbit. If we take cesium, it is having 1. So sodium is more metallic or cesium is more metallic. So that we will see that cesium, because of its greater size, is finding it easier to lose that one electron. So we will say that cesium is more metallic compared to sodium. We will discuss these points now. So what are the factors that decides the easiness to lose electron? As I told you, we have to consider always 2 factors, atomic size and nuclear charge. So first let us come to atomic size. Now to see if the atomic size is more, as I give the example of lithium and cesium. Cesium being at a see here, cesium is in period 6, lithium is in period 2. So number of cells in lithium are 2, in cesium are 6. So the size of cesium would be much bigger compared to lithium. So if the size is bigger, what does it tell us? If the size is bigger, it means that its attractive force by nucleus, if the size is bigger, so it will mean the attractive force of nucleus, means protons with the electron, would reduce as the size increases. Therefore, if the attractive force is less, it is easier for that electron to come out. Means less energy would be required for the electron to come out, or to lose, for the atom to lose one valency electron. So more the size of the atom, it is farther, the electron is farther from the nucleus and it is easier for electron to come out. So it is more metallic. So this point you should learn that bigger the size of the atom, it is more metallic. Now we'll go to nuclear charge. If the nuclear charge is more, when we say nuclear charge is more, assuming that size is same, the size is same, nuclear charge is more, so means it is attracting the electron with a larger force. So when for getting it to remove is difficult. So metallic character decreases. So this you should learn, that if the charge is more, nuclear charge is more, metallic character decreases. If the size is more, metallic character increases. Now, having understood this, now we will be able to see the variation across the period and down the group. Now, elements which are losing electrons to complete their last orbit, they are called reducing agents. So metals are reducing agents because they are losing electrons, valence electrons. Now if we go across a period, then how does the size vary? The size will go on decreasing because of more nuclear charge. The electrons are attracted towards the nucleus. So if we move along the period, the size will decrease. So the size will decrease, it means metallic character will reduce. So you can see that lithium is on left hand side and halogen fluorine is on right hand, highly non-metallic. Gradually the metallic character is reducing. Is it all right? And what will happen to charge? Charge will increase. Nuclear charge will increase as we are moving, but due to increase of nuclear charge, though electron would be bonded with a slightly more force, but the size dominates the behavior. Okay, so size will dominate the behavior. So you can see in the table, in second period, lithium, beryllium, boron, carbon, nitrogen, oxygen. So lithium is having most metallic properties compared to beryllium and others. Lithium and beryllium are metals, whereas boron is a metalloid. Metalloid means in between metals and non-metal, and having properties of both to some extent. And carbon, nitrogen, oxygen are non-metals. So you can see that metallic properties are coming down. Now if we go down the group, then atomic size is increasing. If the atomic size is increasing, it means when the size increases, what will happen to metallic character? It will also increase. So metallic character increases, though nuclear charge also increases, but it influences less. So size is having domination over the behavior. Therefore, the bottommost element in the first period is francium. So francium is highly metallic. Now this is also evident if we see group 14. Carbon is on the top, second period. Then comes silicon and germanium. Now carbon is a non-metal, silicon, germanium are metalloid, and below that are tin and lead, which are metals. So metallic character increased. Top was having non-metal, then came metalloid having properties of both, and then we got tin and lead, which are metals. Is it all right? Now we'll go to non-metallic properties, non-metallic character. Now this would be similar to what we learned in metallic, but in opposite sense. In non-metallic character means those elements which have a tendency to gain electrons. Like whenever I say non-metals, in the mind fluorine and chlorine should come, halogen should come. So they have got 7 electrons in the outermost orbit, so they have to gain an electron to complete that orbit. So non-metals gain an electron, gains the electron. So they are oxidizing agents. Here also atomic size and nuclear charge will decide the behavior of the material. The smaller the size, then greater is the pull with the electron. So when there is a greater pull to the electron, so any electron which is passing nearby will get attracted with a greater force. So it is more non-metallic. So it is opposite. Smaller the atomic size, it is more non-metallic. You can see in period 1, fluorine is on the extreme right and its size is minimum in that period. The nuclear charge, greater the nuclear charge, greater is the tendency to gain electron. It can attract, therefore it is more non-metallic. So atomic size small, it is more non-metallic. Nuclear charge more, it is more non-metallic. Now knowing this, we will see that how does the non-metallic properties behave across the period. Now if we are moving along the period, then what is happening to size? Size is decreasing. So if the size decreases, it is more non-metallic. So therefore we are moving from, we know we are moving from metal to non-metal. And what is happening to nuclear charge? Nuclear charge is increasing. So if the nuclear charge increases, it is easier to gain electron, so it is non-metallic. So both factors makes the element non-metallic. So across the period, when we move from left to right, we are moving from metal to non-metal, or non-metallic character is increasing. Now if we go down the group, if we are going down the group, then what is happening? Atomic size is increasing because number of cells is increasing by 1. So as the size increases, non-metallic character will decrease. And nuclear charge is increasing, but the dominating factor is size of the atom. Okay. Therefore non-metallic nature decreases down the group. So that is why you know that if we take fluorine and chlorine and bromine, fluorine is most active compared to the elements which are below. As we go down, they are less reactive. Their non-metallic behavior is less. Is it alright? So then we'll go to next property. Now next properties are very simple. Then the physical properties we are going. So if we see the density of my first period, it is 0.5, 1.8, 2.3, 2.2, and then others are gases. So we need not write for gases. Therefore what we can see, density is increasing. Similarly, you can see for third period, sodium to chlorine. Chlorine is a gas, and others you can see the density is increasing. It is increasing up to aluminium, and then there is a slight decrease. It is increasing up to sodium, magnesium, aluminium, density is increasing, but silicon, phosphorus and sulfur, they are slightly decreasing. And melting point, you will see melting point increases. See, for lithium it is 181, and for carbon it is 3727. Other are gases, so there is no boiling point for that. And similarly, if we see for group 3, for sodium it is 98. It will increase up to it is increasing. It is first decreasing 98, 650, and so on. And then for silicon it is 1400. And so here there is no, we can say, proper trend, and then it is 44 and 119. Now let us see down the group. If you see down the group, lithium, sodium and all those things, we will find that density is increasing as we go down, melting point is decreasing, and boiling point is decreasing from 1347 for lithium, and for cesium it is 705. But in between there is trend is not totally followed. Like for rubidium, it is 688. It is 688, much less. Okay, then these things are not that important. Then chemical properties are very important. Now the reactivity of the elements depends upon that how easily they can lose or gain electrons. If they are losing electrons, they are metals. If they are gaining electrons, they are non-metals. So how easily? So what we can see, if we go across the period, then group 1, if we go along the period, then first group 1 element would be more reactive compared to group 2. And then we'll not go to transition elements. Group 13 would be less reactive compared to 2. Group 14 would be much less reactive to group 13. And then it will go on increasing, because 17 halogen is very reactive non-metal. So now it has started increasing. 15 is a non-metal, 16 is a non-metal, 17 is a non-metal in increasing order. So this is how the reactivity will change. First it decreases and then it increases. If we go down the group, then what we had discussed now, that metallic properties goes on increasing, but non-metallic for non-metals, the reactivity goes on decreasing. Fluorine is highly active, actinide at the bottom is least reactive. Fluorine, chlorine, bromine, iodine, so reactivity is decreasing. So we go down the group. For non-metals it decreases, but for metals it increases. Is it alright? Then we'll go to next slide. This is very simple. This I had explained to you yesterday also. Atomic number means number of protons. Mass number means sum of neutrons. Sum of protons and neutrons is mass number which are in the nucleus, and therefore number of neutrons is mass number minus atomic number. In symbols we will say A minus Z. Now if we have a good look at the mass number and atomic number of elements, we will find that for lighter elements, in case atomic number is even, then mass number is double, and in case atomic number is odd, mass number is double plus 1. There are few exceptions, like helium, atomic number is 2, mass number is 4. Atomic number is even, so mass number is double. Carbon, atomic number 6, mass number 12. Oxygen, atomic number 8, mass number 16, so it is double. Now you see the exception. Exceptions also learn. Beryllium, 4 is atomic number, but mass number is 9. 4 is an even number. Argon, atomic number is 12, mass number is 40. Okay, so, and if we now let us see the odd numbers. Boron, it is 5 atomic number, mass number is 2 plus 1, 11. Sodium, atomic number 11, so mass number is 22 plus 1, 23. Fluorine, atomic number is 9, so mass number is 18 plus 1, 19. Exceptions. Hydrogen, atomic number 1, mass number 1. Nitrogen, atomic number 7, mass number 14. It is not 15. So this is just you should know. Then as atomic number goes on increasing, then number ratio of neutron to proton goes on also increases. Means initially like we had 50-50. Like so say carbon, atomic number is 6, mass number is 12, means 6 proton, 6 neutron. Oxygen, atomic number is 8, so 8 proton, and 16 microns of number of neutrons are 8. So initially the ratio is 1, but as we move on, the ratio increases. Then once the ratio becomes more than 1.5, they are called heavy metals and they are radioactive. So this number we should learn, that if the ratio of neutron to proton becomes more than 1.5, those elements are radioactive. So with this I am completing this chapter. I hope you have understood it. If you have found this sessions to be useful to you, helpful to you, then please subscribe the channel and press the bell item, so that will give me encouragement to make further videos. Thank you.